Welcome to our lesson on the standard normal distribution and z-score analysis. So in this lesson, we're going to focus on what's called a standard normal distribution. And this is very much related and very similar to the normal distribution. The standard normal distribution has all the same characteristics. The sum of the area under the graph is 1. All of that remains the same. The only difference is the way that it's labeled. When we put our labels below the graph, typically we use our raw data, our x's. What are the values of our variable? When we're talking about the standard normal curve, we are going to be talking about it in terms of z, which tells us how far out from the center we are, from the mean, in terms of how many standard deviations. And when data sets have different scales or units or variability, it's almost impossible to compare them directly. And this is exactly why we use the standard normal curve. Instead of using all the different x's in the different datas, we can stick with always using z is equal to 0, 1, 2, 3, and going this way, -1, -2, -3. So rather than trying to analyze every situation in its own specific context with different means and different spreads and different units, we can standardize the data, and using a calculation called the z-score, this gives us a common language to talk about how extreme a typical value is, no matter what the original units are. So we're taking out the units and we're comparing it based on standard deviations only. So because z, which is also known as the z-score, tells us how far out we are from the mean in terms of standard deviations, our values of z will be the same no matter what the context of the problem is. So if I'm sitting at the mean and z is 0, that means I'm 0 standard deviations away from the center. When I come out 1 standard deviation to the right, that's a +1. When I come out 2 standard deviations to the right, that's a +2 for z. And when we go out again, we get a +3. Typically, most of the data falls between -3 and 3 for the standard deviations. So that's how far we typically go out on the scale here. But it is possible to have to go out to 4 or 5 or 6. Now, we do the same thing in the opposite direction, but we call that -1 so that that negative indicates we're on the left side of 0. So when I go out 1 standard deviation to the left, that's z is equal to -1. When I go out 2 standard deviations to the left, that's z is equal to -2. And when I go out 3 standard deviations to the left, that's z is equal to -3. Now, as far as the distribution notation, when we talk about the normal distribution, and we talked about this in the previous lesson, our notation looks like this. We have x, our variable, with our little tilde, and then n for normal, and then inside the parentheses, we have the characteristics that we want to use to describe the normal distribution. That's the mean and the standard deviation. Because when we're looking at the standard normal curve, the only thing that changes with our notation is instead of using x's, we use z's to indicate we're doing the standard normal curve. And our mean and our standard deviation is always 0 and 1 for the standard normal distribution. For the probability notation, the only thing that changes, instead of using x is greater than some value, we use z is greater than some value. And you can use less than or between. You would just use z's instead of x's. Now, the formula to find your z-score, and this can be used to find the x value as well, given the z. Here is our formula. The x is our data value, m is the mean, and sigma is the standard deviation. Now, if I solve this for x, if I'm given the value of z and I want to find x, then that formula looks like this. It is the same exact formula as this. It just rearranged and solved for x instead. So use this version when you're trying to find z, and then use this version when you're trying to find x. Now let's actually work through an example so this can start to make sense to you and it can come together. A zoo tracks the daily number of visitors during summer months. This number is normally distributed with a mean of 145 visitors and a standard deviation of 25 visitors per day. Based on the provided graph, which we are actually going to make that graph, showing the normal distribution of zoo visitors, find the x values that correspond to the z-scores, round to 2 places. So here is our standard normal curve. It looks like the same shape as the normal curve. The only thing that is different is that we label it with the z's. So again, I'm going to stress this a lot. The z's represent the distance you are out from the center or from the mean in terms of standard deviation. Am I 2 standard deviations out? Am I 3 standard deviations out? So if we're sitting at the mean, then we're 0 standard deviations from the mean. So the center for the standard normal curve is always going to be 0. Then we can come out 1 standard deviation, 2 standard deviations, and 3. When we go to the left, we make those numbers negative to indicate that it's going to the left. So we would have -1, -2, and -3. So these are the z values. I'm going to highlight them different colors so that you can compare to the x's. Now, let's label our corresponding x's. In the problem, it tells us that the mean is 145 visitors. So this is the raw data. This is the data that is in the context of the problem. So because the mean is 145, that's going to go in the center. So when x is 145, the corresponding value of z is 0, because at 145, we're 0 standard deviations out from the mean. Now, if I come out 1 standard deviation, according to the problem, each standard deviation is 25. So if I add 25 this way, so that I come out 1 standard deviation, that's going to give me 170. So the value of x is 170 corresponds to the value of z is equal to 1. If I come out another 25, that's going to give me 195. And then when I come out 1 more standard deviation, that is going to give me 220. So x is equal to 220 corresponds to z is equal to 3. Now, when I go out this way, I'm going to subtract 25. So z is equal to -1 corresponds to x is equal to 120. When I come out another standard deviation and I subtract 25 again, that corresponds to an x value of 95, because I'm going to subtract 25 again. And then when I come out one more time to -3, I'm going to subtract another 25, and that's going to give me a corresponding x value of 70. So in green are my x's, and in blue are the z's. Now, it's really easy to say when we look at this chart, hey, what's the value of z when x is 195? We can look at that chart and say that z is equal to 2 because it's an even unit on that graph. We can see it. But when you're trying to find values that are in between the whole numbers, that's when the formula z is equal to x minus mu over the standard deviation comes in handy.